Okay, we have a different question here, still about errors in expressions. So here they are giving us a cylindrical pipe has radius is measured in the nearest unit. If the relative absolute error calculated in its volume is this, find the absolute error measuring its height. Remember, whenever you make an error in radius or a height of a certain cylinder, it means that there will be also an error in getting also its volume. Now, the one has to get the absolute relative error or in measuring the height. This is how you get the error in the height over the height, modulus absolute. Now it means in simple terms here, we have also to first see the formula for getting the absolute relative error. So meaning we have to go in first principles by also writing. Now what I started with is let sigma r and sigma h be errors made in measuring radius and the height respective, which means that now if there is an error in radius and h, means that there will be an error in the volume also. So the volume for measuring the volume of a cylinder is given by this. So meaning, so an error in measuring the volume of a cylinder will be equal to is that the volume of this cylinder is multiplied with the radius and the height. So that's why I have r. There will also be a small change in r. Remember, we have the square. Then in the height, also a small change in height. So from here, we expand this. So this will be sigma v equal to, I'm going to take v this side. So I'm going to be adding pi into r squared plus 2r sigma r sigma h. Now inside, I'm going to say now minus v. And I take this v inside. So you know that this one is very small, so it's going to be approximating almost 0. So that now our sigma squared r is going to approximate 0. So as okay, so from here, so now my sigma v is going to be, now I'll be adding pi into, now I'm going to multiply this and this, I'll be adding okay, r squared minus v, taking v aside. So expanding this, we shall have v into r squared h plus r squared sigma h plus this time this now 2rh sigma r, then this time this plus 2r sigma r sigma h, the whole of this minus v. But what is our v? Our v is pi r squared h. Okay, now you got that. This one sigma r sigma h will also approximate to 0. So now mean that sigma v is going to be pi into, now remaining with r squared h sigma h. The whole of this will be now plus 2rh sigma r. The whole of this will be 0 minus pi r squared h. So if I factorize out pi, this will give me r squared h minus r squared h, this pi out. So this now, see it will vanish with that. So from here, my delta v will be pi into r squared sigma h plus 2rh sigma r. So now this is the error in measuring the volume. So meaning, if I want to get the relative error in measuring the volume, so my relative error in measuring the volume will be the error in the volume over the volume. Okay, now this will be now, I'll be having now pi r squared sigma h, if I open brackets, then plus 2 pi rx sigma r, the whole over, remember I'm dividing with my volume, which is pi r squared h. As simple as that. Now from there, that needs to be separate. This will be pi h. Sorry, this is sigma h. Sigma h. Divide with, then plus the whole divided by pi r squared h. Why am I doing this first? because they talked about measuring the absolute relative error made in calculating its volume. That's why I'm also looking for the absolute relative error for this. But if you start by getting the relative error over the volume, then after that you shall get its absolute error. Now, it's that now this will go with these two, then also this goes with this one with this, then this with this. So this one will be made with sigma h over h, then plus 2 sigma r over r. Is it? Yep. So this is my delta v over v. Now if I want to take the absolute, so absolute of this, okay, so the absolute of is going to be equal to now absolute of which is going to be less or equal to, now you can easily separate this as sigma h over h and plus 2 modulus over r. And you said if you want to get a maximum, now if this is less or equal to this, now sigma v over v max, this one is telling us the maximum error you can get is, remember this is equal to this and this is less or equal to this, meaning the maximum error you can get is when the whole of this is equal to this. That's the maximum. So meaning the maximum of this is going to be when it is equal to that. So I'm going to start with this 2 sigma r over r, then plus sigma h over h. So this is the maximum we can get. So now they are telling us that the relative absolute error made in calculating the volume is this. So meaning they are giving us that. They are giving us this, and they are telling us that they want us to get this. But are they giving us our radius? Yeah, they are giving us our radius as the sum. You know that sigma v over v is equal to 0.125 from here. If the relative absolute error made in calculating the volume is this, so this is this, comma, they are giving us our radius as radius is 2.5 centimeters. Now we also need to get the error in measuring the radius. Now the maximum error here, this one it was given 1 decimal place, so this one will be 0.5 times 10 power negative 1. Because to get the maximum absolute error, this is what you do. So that this one is going to be 0.05. So now we can type it there and substitute here. So from my sigma v over v equaling to 2 into this sigma r over r plus over h. So we have this as 0.125 equaling to 2 absolute. This is equaling to 0.05 over 2.5, then plus, this is what we are looking for, the absolute error of this. So from there, then you get this, this will be now 0.125 equaling to, this one you can easily multiply, 2, this one will be 0.04 plus over 8. So you can see now our over h is going to be, when you subtract this, it will be 0.085, and that will be our answer. So that's now the relative absolute error in measuring the height is going to be given by that. So that's it, members. We should, well, we are going to see more examples in the next lesson there. Okay.